everyone, this is Let's Can Be Better. We call our algorithm Let's Can Be Better because it can solve COLIEE task 4 on Google Colab for only 10 seconds and achieve the third best ranking as a team. Here we will show you how did it run so quickly and save so much energy in this computing inflation time. We would like to share our new way of processing old algorithm which only takes quadratic time. It is my pleasure to work with Professor Huang Shichun and Professor Shao Xuanlei at the Laboratory of Legal Analytics of National Taiwan University. Here you could see that it only runs 9 seconds. We are honored to attend the COLIEE 2022 for the third time. This is a competition held by University of Alberta. There are 4 tasks in the COLIEE. Task 1 and 2 is the retrieval and entailment of case law. Task 3 and 4 is the retrieval and entailment of the status law. Our team, LNTU, have been attending COLIEE since 2020. We have proposed a high accuracy BERT-based algorithm for Task 3 and won the award that year. This year, we would like to share our efforts on the Task 4. Task 4 is the pooling question and status law entailment, in which we were given several Japanese bar exam questions and their relevant status. Our goal is to determine whether the relevant articles entail the question true or false. As shown in the slide, the corpus of legal questions was drawn from past Japanese bar exams, which were originally multiple choice questions with 4 options. Thanks to National Institute of Informatics, COLIEE officially provided the pre-processed questions with only 1 statement each to be determined if the answer is yes or no. Here you could see that in the given testing pair R0312E, the orange T2 in XML text is the query, and the green article 345 as T1 is the relevant article of the query. COLIEE provided the training data from 2006, which is the Heisei 18th year, which is also written as H18 in the data, to 2020, the year before last year, which is the Reiwa second year, shown as R02. The training data consists of not only the queries and their relevant articles, but also the correct binary answers labeled as Y or N for yes or no. This is different from the test data that only includes the queries and their relevant articles without the binary answer labels. For examples, the H25 14th E is the second statement of the 14th question of bar exam in 2013. The orange T2 in XML text is the query, and the green T1 articles 333rd is the relevant article. In addition, the binary label of yes or no are provided in the XML pair attribute from the COLIEE officials. Our design for the legal textual entailment task 4 is to retrieve disjunctive union from training data and compare them to that of the testing data. We will present our algorithm of preprocessing in this session. Although all our data we processed and submitted to the COLIEE official was in Japanese, we will demonstrate our examples of these slides in English for our dear Jersey audience. From the given 1,086 bar exam questions and their relevant articles from the Japanese Civil Code, we extracted their disjunctive union, which is the union without the intersection as our database. The disjunctive union texts in our case can be recognized as the unidentical subsequence from the bar exam query and their relevant civil code articles. Take the mentioned H25 14th E as an example. The query is in orange and the relevant article are in green. You can see that the identical subsequence that matches together will be removed, and the remaining unidentical subsequences will be our disjunctive union texts. In this example, against for sale of movables with respect to is the disjunctive union texts, and the label Y for yes is the original given label from the COLIEE official. We will output the disjunctive union texts and the given label into a duplet. For the 1086 pairs of training data, we made 1086 duplets into our database and ready to take on the upcoming challenge. How do we process our test data? For each query, we will produce its disjunctive union text again and compare them with the database. Take R0312E from the database of last year as example. After we remove the identical subsequence from the query and the related article, the remaining allow to of movable half will become the disjunctive union text that we would like to compare with the database. Our model will calculate the longest common subsequence matcher similarity ratio from the testing query and our 1086 duplets in database. As a result, the most similar datum of the query in our database will be pulled out. In this case of R0312E, the most similar result is H2514E, which we had mentioned at the previous session. And our algorithm on calculating the sequence similarity ratio with the longest common subsequence is to measure the amount of the intersection and divide it by the summation of both amount of querying disjunctive union texts and the amount of those disjunctive union texts in our database. Correspondingly, the subsequence matcher similarity ratio of the H2514E and R00312E is approximately 0.3, which is the highest similarity among R0312E and all the disjunctive union texts in our database. Well, although it will be much higher in the Japanese version. Well, and because of the label of the most similar datum, that H2514E is Y for yes. So our model will answer the R0312E also as yes into the submitting result. As for the performance, an adjusted raw model achieved 57 accuracy. To improve it, we attempted to adjust the disjunctive union text's detention mechanism to execute with some stopword setup. In the submitted cases, punctuations are chosen to be the stopwords and achieved 60% correct, which is the third highest team in COLIEE 2022. The idea of combining disjunctive union and longest common subsequence stems from the experience of me when preparing for the bar exam. The disjunctive union text, which is the non-overlapping parts of a query and its relevant article, demonstrates a pattern of the question maker's attempts to camouflage examees. That is, it entails a design set of rules to incorporate status with the exam questions. Hence, it is not the intersection of a query that is important, but its relevant articles that is important. But the symmetry differences between those two methods are more important. Perhaps it produces closely estimated answer by catching the question maker's biases. For example, in the case of human observation, when the word Fudosan real property in the status were replaced by Dosan movables in the query, the label is usually nil since they cannot be used interchangeably. On the contrary, in the mentioned examples, when the word the mono things in the status was replaced by those movables in the query, the answer is usually yes, because the former is the broader concept that can be narrowed down to the later one. Nevertheless, our model has some flaws. Some civil code articles that wasn't included in the database while constructing disjunctive union texts that in the case that relevant articles of the unseen query shares several words with a disjunctive union text in the database, our model might be misled. This happened in the situation of R0308A, which is relevant to Article 183, in which our model incorrectly pairs it with the disjunctive union text of H2410.5, which is more relevant to Article 184, and the label is N but not the Y for yes. We assume that the reason is that Article 183 is very similar to Article 184 but with slightly differences. But our model fails to distinguish them due to the lack of information such as the details difference between the different articles. Last but not least, the model we propose this time is simple enough to run without computation burden, which takes less than 1 second for preprocessing the training data and 14 seconds for processing the test data and doing the longest common subsequence comparison. We recognize this simple model has its limits. To increase the model's performance, it may be necessary to do failure analysis more precisely and adding additional rules when constructing the model. That will be our main goal next year. Thank you, everyone. ご清聴ありがとうございました。